Good morning, everybody. Today I'm going to be starting on some chapter 4. We're going to be doing nomenclature today. I'm going to start by just kind of going through our basic chains, and then we'll move into some more complicated molecules, kind of talk through some different structures, and do just a lot of naming today. So most common structure you guys are going to see is going to be what's called methane. Nope, I'm still in, let me see. Just kidding. What am I doing here? There we go. Oh, all right. So CH4, as we start to get a little bit longer, this here, I'm going to put number of carbons, make this table a little more useful. Our prefix for this is going to be eth, so this is going to be an ethane. In general, all of these are going to end with this A and E term. And this just means that it is going to be, essentially this comes from alkane. In the future, when we start doing double bonds, like a double bonded two carbons, this would be an ethene because it's an alkene, but I'm not going to talk too much about that today. So 2 carbons, ethane. 3 is going to be propane. So prop, eth, and meth here are our first 3 prefixes. Our next one is going to be butane. So but, 5 is where it starts to get a little bit more logical. So pent, as in like a 5-sided thing, is usually like pent is your normal suffix for that. So pentane, hexane for 6. Hept for 7. Eight is oct. 1, 2, 3, 4, 5, 6, 7, 8, 9 is non. And 10, which 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's gonna be decane. So usually the starting at 5 and going through kind of usually make a little bit more sense. The first 4 of them are a little bit odd. Meth, eth, prop, and but don't really fall into like a normal, I think, Roman prefixes. Let's take a structure and add something to it. So let's take a pentane. So we have 5 carbons here, and add another methyl, or add another carbon to it. So when you're naming a structure like this here, first thing you want to do is going to be figure out what the longest chain on your molecule is. For this case here, If we started at this section, it'd be 1, 2, 3, 4, 5 carbons. Alternatively, we started up here, it'd be 1, 2, 3, 4, 5. In this case, it's symmetrical, so it doesn't really matter. The next example I'm going to do will make a difference. But for this one, it doesn't matter if we go with the red path or the blue path. So I'm going to use the red path just because I drew that first. And then we're going to have two different choices here, which I'm going to do in red and blue also. So we can either go left to right or right to left. So in this case, I have right to left drawn out. So left to right would be 1, starting on the right end, 1, 2, 3, 4, and 5 here. The goal is going to be to have the lowest number of your substituents. So a substituent is going to be like, for instance, on this example here, we have this CH3 group coming off of this. If we look at our two different possibilities, we have a 2 versus a 4 here. So we want it to be lower. So we're going to go with this red path because red has this CH3 on 2 versus blue having it on 4. So again, going to erase this. In this case, this like, left to right was the best way to go. Now, in terms of naming this, I usually just start with our parent chain. So we have 5 carbons here. This is a pentane. And we have one group coming off of it. That group that's coming off of it is in position 2. So it's going to be a 2 dash. And then there is 1 carbon. So if we think of our table that we did, where we did methane, ethane, propane, butane, etc., 1 carbon was a methane with an ANE at the end of it. If it's a substituent, instead of being the parent chain, we're going to change that suffix. And this is going to be called a methyl group. So YL is going to be what you're going to put at the end of the molecule. So because it's coming off position 2, this is going to be a 2 methyl here. If I add the two of these together, we can get our full name, which would be, you're going to first add the substituents and then end it with your parent chain. So this is going to be a 2 methyl pentane here. Any questions before I do a more complicated one? Okay. So I am going to do this. So not dramatically more complicated, just slightly more. So let's try to find our longest chain first. There's going to be 2 different options. We can go 1, 2, 3, 4, 5, or we could go in blue here 1, 2, 3, 4, 5, 6. So clearly going the, I don't know, what you call it, like up into the right direction, which gets you to 6 carbons, is longer than going straight across. So because of that, this here in blue is going to be our longest chain. So 6 carbons, hexane, we can start by writing that down. From here, we got 2 different options, left to right or right to left. We've drawn in left to right. So right to left would be 1, 2, 3, 4, 5, 6. Taking a look at our one substituent on here, going right to left, we hit this CH3 at 4, versus left to right, we hit it at position 3 here. So 3 is going to be less. Oh, come on. There we go. So this time, this red pathway is going to be the one we want. From here, same concept as last time. So on position 3, we have a CH3, so it's just a single group. So this would be a 3-methyl. We can put this all together. This is going to be a 3-methyl hexane. Any questions so far? Okay. Starting to make it more complicated. Let's only do one of these so far. Oh, that's the wrong thing. There's a pencil. Okay, so let's take a look at this molecule here. Doing some parent chains. 1, 2, 3, 4, 5, 6 versus 5, 6, 7 here. So this is going to be longer. If we tried to branch and put 6 up here, that'd still be shorter. So 7 is going to be our longest chain. Our prefix for 7 is hept. This is a heptane. Now we have 2 different substituents on it. Let's see. So we currently have left to right written down. We need to write in right to left. So 1, 2, 3, 4, 5, 6, 7. To determine which direction we want to go, you're going to add your 2 substituents numbers together. So in the red pathway, we have something on 4 and something on 5. So that gives us a total of 9. On the blue pathway, we have something on 3 plus something on 4, total of 7. 7 is a lower number, so we're going to go with that. Okay, taking a look at our substituents here on position 3, there is this CH3, and that is our methyl prefix. So this would be a 3-methyl. On 4, we have 2 carbons. So F is our prefix for 2 carbons. This is going to be a 4-ethyl. Putting this together is going to be a little bit against what you would normally think. You're not going to use the numbers, you're going to use the letters, and you're going to go alphabetical. So we have ethyl and methyl here. Alphabetically, E comes before M. So for naming this, it's going to be a 4-ethyl, 3-methyl heptane. So some kind of, I don't know, things to pick up on here. At the end of your molecule, There's no space here. This is all one word, methylheptane. In between the two groups, so between the methyl and the ethyl, you always add a dash to separate. Okay, I'm going to give you guys 2 molecules to draw, and then we'll go over them together. Okay, so take about, I don't know, 3 or 4 minutes, try to work through these, and then we will go through them together. Something I realized I didn't talk about for this first example, if you have, for instance, 1, 2, 3, 4, 5, 6 versus 1, 2, 3, 4, 5, 6, but one of them has a substituent on it, like this 2 here has the substituent, but this one doesn't. So there's, I don't know, 2 substituents on the left path and 1 on the right path. Go with the one that has some more substituents. So for this one here, when you're just counting your longest chain, you would go through this red path. Okay, first one here, longest chain with the most constituents. I drew it in red. We can also go the other direction. Taking a look, our red pathway has a substituent on 2, 3, and 4 here. Well, I guess I'm going to talk about that on the fly. Okay. So 2 plus 3 plus 4, 7 is 9. Our blue pathway, we have something on 3, 4, and 5. So that is 12. We're going to go with the red pathway. All right. 6 carbons is a hexane. We have at position 2, we have a CH3, so that is a methyl group. On position 3, we have a ethyl. And then position 4, we have another methyl. So I realized I didn't talk about how to do 2 methyls, and I'll give you guys the crash course of that while I'm doing this. So we're still doing alphabetical, though. So E comes before these M's. So for naming our molecule, we're going to start off with 3-ethyl. When you have more than one of the same thing, so we have 2 methyls here, the way you can write this is going to be 2, 4, and then we're going to use the prefixes for this. 2 is going to be dimethyl. And then our parent chain, which is hexane. So in general, if you have 2 of something, you're to use di. If you have 3 of something, you would use tri. 4 is going to be tetra. 5 would be penta. You're probably not going to see more than 5, but after that, it's the same. It's like hexa, hepta, octa, non. So after 4, it lines up with your normal naming. Okay, let's take a look at the second one. Should be a little bit more straightforward. Longest chain, 1, 2, 3, 4, 5 versus 4, 5, 6. Okay. So going straight across is going to be your longest. Go the other direction. Why did I do 2 1s? So what happened? Let's talk out loud. 2, 3. There we go. So it's 4, 5, 6. We have a substituent in red off of 3. We have one off of 4, total of 7. In the blue direction, we have one off of 3 and one off of 4. Okay, so we are going to talk about this now. Sorry, I keep jumping ahead. So in order to do this one here, we're going to, when you have the same number on both sides, this is going to let us, we're going to use alphabetical. So we have I'm just going to pick one and see which one's right. So if we have an ethyl on 3, or I guess just ethyl here, and then methyl here, E comes before M. So we're going to make it so that the E has the lower number. So this is going to be a 3-ethyl, 4-methyl. Versus having, if we did this the blue way, it would be 3-methyl, 4-ethyl. So we want the one that comes first in the alphabet to be the one that has the lower number when our substituents add up to the same amount. So these are kind of rules on like when you hit the same thing, and then these rules start applying. Okay, So we're going with the red path. Get rid of some of this. We have 6 carbons. So we have a hexane. Putting them in alphabetical order, this would be 3-ethyl, 4-methyl, hexane. All right, so I'm going to kind of review that with 2 molecules. Maybe just 1 molecule that has both of it in there. So oh, that's gonna be hard to do, isn't it? Well, yeah. So for this here, if we're counting right to left, 1, 2, 3, 4, 5, 6, 7, 8, 9. Can't count. Okay. This would be a nonane. We could also go in the other direction. 1, 2, 3, 4, 5, 6. I should do it in a different color. Okay, so for this example here, we have 2 methyls in red on 4. Oh God, what did I hit? Plus 2 ethyls on 6. This is going to make me do math, give me a total of 20. In red, we have the same thing, 4 plus 4 plus 6 plus 6. So that doesn't help us. From here, we have to look at what the substituents are. So these are both ethyls. These are methyls. E comes before M. So we're going to favor it to have our ethyl be first, which would be, in this case, having our ethyls be on the 4 position versus having them on the 6 position here. So I want the 6 still. No, wait, I picked the wrong one, didn't I? Yeah, this is the one I want. There we go. Okay. All right, from here we're doing just kind of our normal naming. So 9 carbons is a nonane. At position 4, we have an ethyl. At position 4, we also have a second ethyl. Position 6, we have a methyl. 6, we have a second methyl. So as I said, if you have more than one, you're going to start using these prefixes, di, tri, tetra, etc. For this molecule here, we're still going to use the prefix, the original prefix. So even if it's diethyl, you don't count it as D, you count it as E. Same thing for dimethyl. We're still using the E and the M here when you have multiple of them for naming this. So E comes before M. This is going to be a 4 diethyl, 6 dimethyl, nonane. Some housekeeping notes. You separate them by commas. And then things like diethyl is one word, dimethyl is one word. Okay, any questions before I give you guys some to work on?
I have a quick question.
Yes.
So for example, how we have diethyl and dimethyl, do we necessarily have to write like 4,4 and 6,6, or could we just have like 4 dash diethyl?
So the reason that you need to write it is because if you had something like this instead, you would have, in this case, I'm not going to change the methyl part, but this would be 4, 4, 6 triethyl. It's not implied that they don't have to both be on the same carbon. Does that make sense?
Yep, thank you.
Yep, you're welcome. Okay, so I'm going to draw a couple of these out, have you guys go through them. I'll give you guys maybe 5, 6 minutes, and then we will go through them together and then take our quiz for the day. Maybe 3 of them. Okay, so take about 5 minutes. At 52, we'll get together, name these 2, and then we'll do our quiz. 3, name these 3. All right, so let's start with this one on the far left here. I'm going to erase the bottom one, draw it back later. So our longest chain is going to be 1, 2, 3, 4, 5, 6 here. Let's take a look at it in the back direction. We've got in red a substituent on 2, 3, 2 substituents on 4. So that's a total of 8 plus 3 is 11, so 13 here in blue. We've got 3 plus 4 plus 5. So 6, 10, 15. So red's going to be our better pathway here. All right, we've got some substituents. We've got a, so 6 is hexane. Substituents, we have 4 methyl, another 4 methyl, a 3 methyl. I don't know why I did these out of order. Should have gone the other direction. And a 2 methyl. So putting that all together, that is a 2, 3. Oops, that's a really bad 3. 3, 4, 4. Tetramethyl hexane. All right, I'm going to do the next one, and I might save the last one for Wednesday. Taking a look at our longest chain, 1, 2, 3. Oh my God, I can't draw. 2, 3, 4, 5, 6, 7, 8, 9. We could also go on 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's going to be less. I accidentally deleted the methyl there. So that will be our longest chain. If we branch the other way, this would be 7, 8, 9, so that's less. All right, we've got a substituent. Get rid of all this stuff. On 3. On 4, 5, 6, and 7 here. If we go the other direction. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We'd have 4 plus 5 plus 6 plus 7 plus 8. That should be a bigger number. So this is 10, 20. This is 25. This one is 12, 12, 24. This is about 31 if I did the math right. Naming our substituents. So we have a 3 methyl, 4 methyl, 5 methyl, 6 is going to be propyl, and 7 is again methyl. M comes before P alphabetically. We've got 4 of them, so this is a 3, 4, 5, 7 tetramethyl. 6 propyl decane. Because the longest chain is 10 carbons. Okay, I'm gonna stop here. I'm gonna have you guys turn your cameras. We're gonna do a quick quiz, and then I will let you guys go for the day. Let's see. So this quiz is gonna be really similar to the one we took on Thursday. The only difference being that I want you to fill in these two sides of your equation. So the two right sides of your equation here. So only one structure this time, but filling in the right of it.
Could you zoom in a little bit?
Yeah. Better?
Yeah, that's perfect. Thank you.